Yeah, recording is also started. So now if we want to take this, we'll open the Excel sheet. Excel sheet. So this is the Excel sheet you have. So now in this Excel sheet, you can represent your data. So first you have to feed the data into the Excel sheet. So in the Excel sheet, suppose this will be your year and this will be your price. So there will be like two datas, the year and price. So year is like 2000, then 2001, 2002, 2003, 2004, and maybe 2005. So you have to represent the prices over the years. What is the price change over the year? So this is the years, and price here maybe your 100, your 102, then 99, 68, maybe 112 or 150. So that suppose this is the data given to you. Now you have to make the representation in this in the pictorial view. So let's suppose we'll first make this data in the form of your charts, like maybe a line chart. So line chart is, so the line chart is like you have to select this and you have to go to insert. In the insert, there will be like the various pivot table, pivot chart. So we have to make a like line chart. So for the line chart, we have this charts available. So when you click on these charts, it will give the various options. So this is the chart available. In this, we have a years. One second, this is not the appropriate graph. So here is the chart, like this is your line chart. Insert line chart is there. So we have to select the data first. So we have to select the data, go to this line chart option. So here it is that we have to select which line chart. So here it is like this. So now, but it is representing year and price independently. So that is not we required. So we will change this to, we will insert the line chart on this and make it like this. The option will not come. This is like series 1 and 2. This is will be taken as independent. So which we don't want, because this is the like independent data is taking one for this, but we want the interaction. It is like in 2000 it has to be taken on the x-axis and y-axis on the in the prices. So we have to do like that, but this data will not representing in this way. So for that reason, why it is not showing? There is an option for select data. Here it is. So maybe there is a difference of WPS office in this, in my system. Otherwise, it is options are there. In this, options are also there, but there is an option of add data to it. अभी आया था ऑप्शन ऐड डेटा का. Hello. So there is some issue in going on in this. क्या issue आ रहा है? I cannot understand it. Select data, year and price. So data is 0. No. Yeah. So see this. Now we have selected this. So this is your line graph is showing like this. So line graph will be like 100, 102. So first year it will be like 100, in next year 102. The movement of this has been shown to me. So if we'll change like this data to maybe 200, so automatically this graph will automatically change. So this may be your 300 and so on. So there is a dip at 68, then 112, and then 140. So this data will show that the line graph movements of the. So this pictorial chart will represent the price movements. Agar, now if I give this data and this tabular data and this pictorial view, so which is more clear, which is having more information, you can say. So on the pictorial view you have more precise information and it can be more easily, you can link with that. So that is the advantage of the pictorial view of the representation. So one is your like line charts, then you can have a bar chart. So in bar chart also, one is this. So you can have a multiple also. So let's suppose we have to compare two things. So this is the price of maybe wheat. So this is the graph for price of maybe a wheat. Now we want to find for price of rice. So another is rice prices. So rice prices is maybe your 200, 230, 200, 140, and 156, 150 again. Now we want to make the line graphs and comparison. For that reason, we will select both and then again we'll go to insert and the line graph. So this will show like series one for maybe a wheat and for orange color it was your rice. So we can compare with the same period on the same part, like on the 2000 the price of wheat is this much and rice is this much. And if we can select if this and then insert line graph, so it will give the like labels also, price of wheat and price of rice, because we have selected this also into this. So that is your line chart we have made. So the purpose is basically to represent in the graphical form. And now if you want to inlay maybe a pie chart in a, sorry, not in the pie chart, but in the bar graph. So here you can go with the again insert again the chart. So if you go to the chart, here we have a different available. So bar we have plotted. So if you insert on this bar, so if you click on this bar, this will comes the pie chart or the bar chart. So in that way, you can create your graphs. But the same, the purpose of like pie chart. Now, if we want to make a pie chart of the data, so pie chart cannot be applied on any data. So pie chart will apply in the case when we have the, you can say the composition. Composition means you can have a pie chart in case when we have proportions data. Proportion means out of 300 we have 100 in one, 150 in the another. So the total becomes like a percentage. So in case of the percentage form of the data, you can have a pie chart. So again, we'll take the example. So suppose we have a total of 100. So among that, 20 is first component, like 20 is uh, you can say, you can take the example like out of 50 students, 20 students are there who have scored less than, yeah, ऐसे ना करो. There will be like you are maybe 100 students, you are like 104 students. Out of it, from 104 we say that 25 are from MBA, 25 are the MBA students. Then MCA we have maybe 40, MA we have 40, engineering we have, एक second. So engineering we have suppose 20 or 30 you can say. So 20 plus 40, it becomes 70, 70 and 95, and 5% maybe in maths. 5 of maths. So that comprises of total of 100. So if we make a total of this, so that becomes the 100. Or you'll take not 100, maybe 100 maybe get confused to you. So we'll make it 7. So that becomes 102 students. So this is the composition of 102 students in the various courses like MBA, MA, engineering, and maths. Now we want to plot this. Now this data can be plotted on the pie chart because this is the total of 102. So we want to show the proportion, like how much of 102, how much percentage of MBAs are there, how much percentage of MA is there, and so on. So we can select this data and we can go to insert and we can go to a pie chart. So this is your pie chart and we have selected this. So this will show like this orange, this first is like MBA, then this 40 students are of MBA, engineering is of 30, and 7 is for math. So this will show the pie chart of those students comprising of the courses in like MBA, MBA engineering, or math. So in this way, we can convert our data analysis and we can show the data into the pictorial view. So we have a various types of charts. If you go to the charts available, so if we change this chart type, so we have a scatter diagram, we have a bar graphs, area graphs, line graphs. So n number of charts are there, but majority of the time we are representing the data in either pies or line or bar. So that will be the basically three charts we are normally using to represent the data in these forms. So, but it is not like the pie chart. We can make pie chart anywhere. In the initial example, when we have to describe our prices, like when we are describing our prices, it is not possible here to represent the data in the pie charts because pie charts will also always compare like the prices, which is not like total has to be, there is no proportion data. So from proportion we can take out as the pie charts. From other data we can make the another charts like line, bar, and all that. So in the pie charts or the bar charts also, we can show the multiple things on a single graph by having a different colors. You have seen the pie charts or bar charts. So the different colors will represent the different information on the same chart. so that you can compare the thing with the same time movement. In the same time movement, one is at which position, other is at which position. So we can have a same graph in multiple issues so that we can, because otherwise if we have three things, now if seen this, suppose we have this data, price and wheat independently. We have a price data and we have a wheat data independently. So we cannot compare the things with this. But if we make a pie chart, a line graph or a bar chart of the same in the same graph. So like suppose you have selected this and you have insert the chart. So blue will show the wheat, orange will show the price of the rice. So at the same time, you can judge what is the difference between the. So at the same moment, you can compare what is the price of the rice and versus price of the wheat. And the blue chart will show the prices of the variations in that will again explain you the movement of the prices in the wheat, and orange will show the movement in prices in the rice. But if we want to compare what is the difference of the rice and wheat in 2001 itself, so we can compare these two, that what is the difference of these two prices in that. So in that way, you can create your charts on and all. And if you're double clicking on this, so this becomes your active now. You have to get if add element or colors you have to change. You can work out on this particular thing to get more presentable the data is. So that may be your the case of the graphical representation. That is one of the form to represent the data. Another way is now this is after the graphical representation or after the pictorial representation of the data. Now next term is your we can have through this central tendency. So now there comes the it is called a descriptive analytics. So descriptive analytics of the data comprises of three things. So when you have to describe your data, so you have to describe in three ways. One is the measures of central tendency, then you have measures of dispersion, and the last is your measures of the first is your measures of central tendency, measures of dispersion, and the measures of distribution. So these three measures are available to us to analyze the data, and these three measures have their own way. They have made their own significance. It is not like that it is optional either to calculate central tendency or dispersion or distribution. The three has their own implications, had their own meaning. So we have to see that for the complete information, we have to give a descriptive complete data. Like we'll take the example again. I have taken the test of the class and maybe the marks is out of 60. So we'll open a next spreadsheet. Maybe we have a students data from a class of like 30 students. So 30 students will take and we will collect the data from the students. So like here we have S1, S2. So we have a data for suppose maybe 30 students. So we'll make a data sheet. So we'll make a data sheet for 30 students. So this will be the 30 students we have named S1 to S30. Now we will take its their marks. So the marks of the student will be any random mark out of 60 I am taking. So any random marks I can take. Clear? So these are the marks of the 30 students. We have supposed that these out of 60 the marks is. Now we want to represent this particular result. So this is the result of each and every student what the independent student have scored. Now we have to represent this information to the higher management, that what is the performance of the class. So if I share this performance, like I have, if I share this particular Excel sheet to the management, S1 to S30 and their marks, if this information has some meaning to the management or not. If this particular information has certain meaning to the management or not. If management can pursue something from this, seeing the individual marks of each and every student, the management cannot be able to understand what is the overall performance of the class. So, but we have to clarify the management that what is the overall performance of the classes. So we have to make it some analysis so that we can say that the class performance is maybe below or above or at the required level or whatever it is. So for that we have the first is the measures of central tendency. So for that we can calculate the measures of central tendency. So what the central tendency will say? So the measures of central tendency is, so measures of central tendency says we have to um, measure the central value of the data. So central value I want to calculate that this is the central value of the data which will represent that this is the average performance you can say of the class. So the central tendency can be measured by the three ways. Further central tendency can be measured through three, that is your mean and median and your mode. So there is three measures to measure this central tendency: mean, median, and mode, and each has their own implication, has their own meaning. So it is the statistician who has to see whether the more information will come from if we are calculating mean, or if we calculated from median, or we are calculating from mode. So that the statistician has to analyze that which central tendency measure has to be taken so that I can get the appropriate information. The appropriate and correct information I'll get by either mean, median, or mode. So I have to see like what is the type of data available, what is the situation available to me, and if it is mean is more meaningful to me or median or the mode. So we will understand that thing later on, that where we can use mean, median, mode. But the thing is, first we have to know what is the differences between and how we can calculate this mean, median, and mode. So for that particular reason, I have to do like, if anyone is having any doubt, they can like stop me at that point only. Fine. So because each and everything is interlinked to each other. So if you have any doubt of any kind, you can ask me at that time only. Fine. So now you have to check for this S1 to S30. So if we are calculating the first, that is the mean. So mean, the another name of the mean is like average only. So everybody knows that how we can calculate the average. So average is sum of all the elements divided by the number of elements. So if we have to do this, so we can simply make this addition of all the elements. So because we are working on the Excel itself, so we can simply make the sum function of the Excel to calculate this total sum. Otherwise, we have to do this sum manually. But because we have the advantage, we are working on the Excel itself. So we are making the function of Excel to calculate the total sum of all the elements. And then we have to divide it with the number of elements. So for that, we will use the count function. So is equal to count of all these elements. So it will give the 30. So we will use the count function of the same. So it will return. So count function of all these 30 values. So it will give me the 30. So this is the count and this is the total. Otherwise, I can mention it like 30 also, because I know this is the 30 values. But the thing is, if some values get edited, or maybe some new students will add it, or maybe some students are left, so this count function automatically will change the values. So that's why we are using the count function, and the mean value becomes like, if we are taking the mean value, that is the total divided by the number of elements. So this is your total and divided by number of elements is in the count. So you will get as 37.47 is the mean. So 37.47, that will be the mean for this particular data, which shows that out of 60, the average performance of the student will be like 37.47 marks. So I can say to the management that the average performance of the class will be like 37.47 marks. So the students are more or the less like on the average of 37.47. So this 37.47 single figure to the management, that will depict more information to the management what is the average performance of the class rather than giving individual marks of each and every student. So that's why the mean will depict the more information to the management as compared to the individual marks of each and every student if have making it. So that is the mean. Now the median. Median is like, if we are talking of a median, median is again a measure of central tendency, but it works on like frequency. So median says the definition of median is that value which divides the complete data set into two equal parts. So like suppose we have a 30 of a data sheet. Like suppose we'll take one more data. One second. We will make one more data to it. We'll make more data for one more student, like 31 students are there, which will be the data like 45. Fine. So and in the count also we have to like again do the things of count. Three. So this becomes 31 now. So this is your new data now. Now you want to find the median. So median says median will is that value which divides the complete data set into two equal parts. That means that value in which we have 50% of the elements are below it and 50% of the elements are above it. So for that reason, you have to first make this data into the ascending order or descending order, because initially it was in the random manner. But median is that value which divides the data set into two equal parts. So you have to make this data in some order, maybe ascending or maybe descending. So we'll make first this data in the form of ascending order. So for that reason, again, because I am working with the Excel, so I'll take the advantage of Excel to sort the data. Otherwise, you have to manually sort the data. Because we are working on Excel, we have the privilege that we can have the sort function in the Excel to do it faster. So we can simply apply the sorting ascending. So when we are clicking on this ascending, this will create all the data into the ascending order, starting with 12 to 60. So this is the 31 data we have sorted and become the ascending order. Now after this, we have to check it is 31 elements are there. So median is the one which divides the complete data set into two equal parts. So two equal parts means if 31 is the total element, so 15 below and 15 above. So we'll take the example of short figure like 2, 1, 2, 3, 4, and 5. So we'll take the example with the 5. So the median is 3, because two values are below this and two values are above this. So median value, the 3 is the value which divides the complete data set into two equal parts, two below and two above. So 3 is the value which divides the complete data set into two equal parts. So that's why it is the median value is 3. But now what is the median for this data? What is the median for this data? So if we check this particular data 113500, so what is the median of this? So the median of this becomes again 3, because 2 is below it, 2 is above it. So that is the drawback of median here. Why the median will not change? If the data will be this, if the data is 1, 2, 3, 4, 5 or 113500, the median will remain the same, that is 3. The reason is because median will not incorporate each and every value into its calculation. Median does not take each and every value into its calculation. Median will only take the position, like that position which divides the complete data set into two equal parts. So until and unless this this becomes 2, then only the median value gets changed. But if that value has like the median value, middle values does not change, so that will not change because it will not incorporate each and every value. But if we are talking of mean, so the mean of this and mean of this is not same. So if we talk of the mean of the same, we will take the sum. So the mean becomes 15 divided by 5. So for this it is 3, and for this is equal to 110 divided by 5. So it's 22. So the median will remain the same. That is 3. But the mean is not same because it will take into corporate each and every value into its calculation. So that's why the mean is the most effective way to measure the central tendency. But there is sometimes we have to use the median also in some situations that I'll discuss you maybe after this how we can calculate the median and all. So where we can make these calculations through median. But otherwise, most effective way to measure the central tendency is your median itself. Fine. So now if we are like this data, so if we are now coming to this data of 31, so the median value is the one which divides the complete data set into two equal parts. So 15 values below and 15 values above. So that means 16th value is the median. So if we count from this data from the first, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this 45 is the, so we will talk of like this. So we make like sequence of the numbers 1, 2, and then up to maybe 31. So here the 16th value is the one which is the median. So 16th value of 16th term, that is 45. So 45 is the median of our data. So the mean of the data will be like 37.70 and the median comes out to be like 45. So if we'll talk of the median of our data, that will be equal to the 45. Fine. Any doubts in the median and the median? Now, how we can calculate this median? So this is the 31. We have to check it like 50% below, 50% above, and so. So in that case, we have to find this. We have find this median as 45. Now, the general principle of the median become the formula for the general, like now we have to check if the number of terms are odd or even. So if the number of terms are 31, so 16th is the exact middle, 15 below and 15 above. But if I have added, suppose this data, I'll again take this data because short is more easy to explain and to understand. So suppose we have added one more element, 1, 2, 3, 4, 5, 6 now. So now the total of number of elements becomes even. So now what is the middle term? It will take this as a middle term. There will be 2 below, 3 above. It will take 4 as a middle term, then 3 below and 2 above. So there will not be exact middle term. So but if we consider these two as a middle terms, these two both has a middle term. Now it will divide the complete data set into two equal parts. So in the case of even, we have two middle terms. In the case of odd, we have only one middle term. So as that's why I have added one more student into it, or 31. So here the 16th is the median, and how we can calculate this 16? This will be the total number of elements, which will be equal to n plus, so the median value is equal to, the median is value of, you have to remember this value of, it is not n by 1 plus 2. The value of n plus 1 divided by 2th term. So value of n plus 1 by 2th term. So that will be the, so value of n by 2th, n plus 1 by 2th term. So that becomes, n here is 31. So 31 plus 1, 32, 32 by 2 is 16. So value of 16th term. So we can calculate the counting here. So 16th value is 45. So that's, in this way we can find the median, like the value of n plus 1 by 2th term. So n by 1 plus 2 is 16. So 16 is your non-median. So 16 is not your median, but the value of 16th term, that is your median. So that becomes your 45. Okay? So the median value becomes 45 in this case. So that is your, but in case if it is a even, So in case of even, there will be a data for like 30. एक सेकंड होल्ड करना. स्टूडेंट्स एक काम करो, 5 मिनट्स की ब्रेक लो, 5-10 मिनट्स की. ठीक है, एक काम आ गए, 5-10 मिनट्स की ब्रेक लेके फिर रिज्यूम करते हैं क्लास.
दो तारीख को टिक्का करने जाएंगे फिर सिस्टर आपके करते हैं टिक्का
ये मतलब सगाई सुनी का क्या? पहले हमारे साइड इसको टेवा बोलते थे, इसमें टिक्का टक्का करते थे शादी से कुछ दिन पहले. अब ज्यादातर सिस्टम बंद हो गया.
हमारे तो करते हैं जैसे जब रिंग सेरेमनी होती है, रुखा होता है, तब तो हमारे लड़के वाले आते हैं, लड़की के घर। अब टिक्के पे हमारे लड़की वाले जाते हैं लड़की के घर,
हेलो,
नारियल वगैरह देख जाते हैं।
यस
Yes,
सर
sir.
लड़के के आते हैं।
हमारे में
your
स्पेशल
lecture has been recorded
ज्यादातर
also.
तो उसी टाइम
Recording is on, so don't
लड़की के
cross
घर
talk
शादी
in
होती है।
between.
अगले दिन मतलब लड़की को ब्याह आते हैं, उससे पहले दिन सगाई में जाते हैं लड़की के घर।
पहले दिन जाते हैं आप लोग? सगाई पहले नहीं करते?
पहले दिन ज्यादातर पहले।
प्लेटफॉर्म ऐसी बातें करने का।
इधर मान ली कल शादी है, कल बारात आएगी।